Enzymes are defined as biological catalysts. They are specialized molecules whose function is to catalyze or speed up reactions taking place in the cell. There are thousands of different enzymes in the cell, each catalyzing a specific reaction. Enzyme is derived from a Greek word and equals in zyme equals yeast. Zymosis is a Greek word that means fermentation, a process carried out by yeast cells. Ancient Greeks were using this process in making vinegar, yogurt, dahi or curd, cheese and wine. Louis Pasteur in 1860 recognized that enzymes were present in yeast cells and that whole yeast cells are essential for fermentation. However, in 1897, it was shown by German chemist Edward Buchner that cell-free extracts of yeast could ferment sugars to alcohol and carbon dioxide. J.B. Sumner in 1926 was the first to isolate the enzyme amylase in pure crystalline form. He also proposed the concept that enzymes are proteins in nature. In the period from 1930 to 1936, pepsin, chymotrypsin, and trypsin were successfully crystallized. Properties of enzymes. 1. Most but not all enzymes are proteins in nature. Only a few RNA molecules are known that can catalyze reactions. These RNA enzymes are sometimes known as ribozymes. 2. The basic function of an enzyme is to increase the rate of a reaction. Most cellular reactions occur about 1,000,000 times faster than they would in the absence of an enzyme. 3. The reactant of an enzyme catalyzed reaction is called the substrate. Most enzymes act specifically with only a given substrate to produce products. If you change the enzyme, reaction will not occur. Thus catalase will not be able to convert starch to glucose. All enzymes show specificity in the substrate they use and the type of reaction they catalyze. For the first step in an enzyme catalyzed reaction is the binding of enzyme to the substrate to give enzyme substrate S complex. The S complex then breaks down to give products E plus S, S plus P. The site on the enzyme where substrate binds and where catalysis occurs is called active site of enzyme. 5. Each chemical reaction has an activation energy barrier. Lower the activation energy, faster is the reaction. Enzymes work by lowering the activation energy of the reaction. Enzymes use an alternate reaction pathway which has a lower activation energy than that of the uncatalyzed reaction. 6. The free energy change delta of the enzyme catalyzed reaction and uncatalyzed reaction are the same. Thus enzymes cannot make a reaction proceed that is thermodynamically unfavorable. They only speed up the rate at which equilibrium is attained. 7 enzymes remain unchanged in the course of reaction. Some enzymes take part in the chemical reaction and are chemically modified, but they are regenerated at the end of the reaction. Since enzymes are catalysts, they are needed only in small amounts. 8 enzymes are sensitive to heat and are inactivated at high temperatures since they get denatured and lose their 3D structure. Their active site becomes distorted and cannot bind to the substrate. 9 enzymes are also sensitive to pH. They work best at a particular pH, optimum pH. For example, pepsin in the stomach has an optimum pH of about 2, whereas salivary amylase has an optimum pH of about 7. 10 enzymes increase the rate of a reversible chemical reaction in both directions, forward and reverse.